Good morning, everyone, or good afternoon, or good evening, wherever you happen to be in the world. Thank you very much for joining us today. My name is Tim Rains. I'm the regional leader for security compliance business acceleration in Europe, Middle East, and Africa for worldwide public sector, based in London. And today I'm joined by Mr. Dave Walker, a solution specialist architect for security and compliance for Europe, Middle East, and Africa as well. And
Hi.
we're super. Go ahead, Dave. Introduce yourself.
Yeah, well, you just did, Tim. I'm just saying hello.
So it should be easy to tell the difference between us. Dave's got a proper accent and I've got some type of accent. But we're super excited to be discussing encryption and key management with you today. We've got a lot of content to cover, which is why we've allocated 2 hours for this particular webinar. I'll be pleasantly surprised if we actually get through all of that in time, but we're going to do our best to do that. Okay, and we've got a bunch of people here to help us as well in the studio to help us answer your chat questions. So if you have questions during the webinar, you can put them into the chat window, and we've got some solution specialists around security and compliance here in the studio with us. We've got Andy Bunn, Stephen McDermott, and Mr. Orlando Scott Calley. And so they'll be happy to answer questions as you put them into the chat window. All right, so with that, let's get started. So as I mentioned, we've planned to cover a lot of content today. And we'll focus this webinar on protecting data at rest. And the AWS services and tools that help our customers do this. We won't really be covering encryption for data in transit during this webinar, as we just won't have enough time. So, look for another webinar in the future focused on protecting data in transit, but the primary focus of this particular webinar will be protecting data at rest. And this is, they're both super important. And it's just the vast amount of information that we have to go through today that will prevent us from, doing them both justice. So we're gonna focus on data at rest. So in this webinar, we'll do a deep dive into client-side encryption, server-side encryption, the AWS key management service, AWS Cloud HSM, and how those can be used together where requirements might necessitate that. There's just a ton of stuff here. As you see, once we start going into it, we'll start sort of high level and get deeper and deeper as we go along. All right. And so why this topic? Why did I pick data at rest, protecting data at rest for this topic? Well, I've talked to a lot of, CISOs, chief information security officers, chief technology officers, chief information officers, data protection officers, general counsels. I've talked to lots and lots of these folks over the years about data protection. And I've had many conversations about, governance, risk, and compliance. And so very often, whatever conversation we start with, we end up talking about encryption and key management. Now, encryption and key management doesn't solve every problem. There's other controls that we won't talk about today that we have for data protection as well. So we're really just going to focus on encryption key management. But generally speaking, no matter what the conversation where we start with, these roles always want to talk about encryption and key management at some point in the conversation, because these are super important technologies. And so this is why we're focused today on encryption and key management, specifically for data at rest. Okay, so there's lots of reasons why organizations use encryption and key management. So probably the biggest ones are maintaining confidentiality and integrity of data. So that's core. In addition, encryption and effective key management can potentially help organizations meet some of their compliance obligations and mitigate some of the specific risks they have in mind, including things like unauthorized access to data. Okay. So then, the question is, if encryption and key management are such powerful controls, why haven't organizations been encrypting everything all the time? And, besides the historical challenges of the complexity and performance impacts related to encryption, traditionally there's been a tension between securing data and operationalizing data. So it can be hard to find the right balance between securing the data and then ensuring the data can be used to make timely decisions to achieve business objectives or public sector organization objectives. So if the data protection controls make it too difficult for authorized users to find, access, and use data, then the value of that data can be degraded or even lost completely. So this tension's been there, for decades, and it's very tough. So what we're trying to do at AWS is we're trying to, the model that we're trying to get to at AWS is this concept of ubiquitous encryption. So protecting data in transit and at rest using encryption and key management options. So if you're using, for instance, AWS Key Management Service, which we'll talk about quite a bit today, you can restrict access to all of the keys being used using policies, defined using identity and access management, and you can also get a record of every call to KMS using AWS CloudTrail. And so what we're trying to get to here is a model where we're helping protect your data from your on-premise environment into the cloud, between the different services that you use inside the cloud, and protect that with a range of key management options depending on what your compliance obligations look like and what your requirements are and what specific risks you want to mitigate. And so there's a whole bunch of controls here. And again, we're going to focus just on a few of them. So encryption, key management, specifically for data at rest, but be aware that there's a ton of things here that AWS is doing around protecting data in transit, IAM, and audit as well. Okay. All right, so let's start by discussing how we protect data at rest, specifically using encryption. And let's look at some encryption-related concepts so that we're all sort of on the same page. We're going to focus on symmetric key encryption. And it's called symmetric key encryption because the same key is used to encrypt as well as decrypt the data. So the performance characteristics make symmetric key encryption a really good choice for encrypting large amounts of data. And to encrypt data, as you can see on this slide, we're going to provide two inputs to the encryption algorithm, a data key and then the plain text data to be encrypted. Okay, the process then produces encrypted data. And to decrypt the data, the inputs provided are the data key and then the encrypted data, which will produce plain text data. Okay, so now you kind of have an overview of the general symmetric key encryption, decryption process and some of the terminology that we're going to use throughout this webinar. All right, so what about the encryption algorithms themselves? So we're not going to spend a ton of time on the mathematics or the anything like that here. I'll just introduce a couple of the encryption algorithms that we use at AWS. And if you want more information on any specific algorithm, there's a URL here at the bottom of the slide that you should check out because it'll get right into detail about some of these algorithms. But essentially, an encryption algorithm is a formula or an instruction series that converts plain text into unreadable ciphertext. Algorithms use advanced mathematics and one or more encryption keys to make it relatively easy to encrypt the message, but virtually impossible to decrypt that message without the keys. So AWS uses AES algorithm in GCM with 256-bit secret keys. And again, if you're interested in learning more about these different algorithms that we have listed here, please check out the URL at the bottom of the slide. All right, so the next concept that it's really key to what we're going to be discussing today is called envelope encryption. Envelope encryption is a strategy for protecting the encryption keys used to encrypt the data. So first, as you can see here, we encrypt the plain text data with what we call a data key. Then to protect the data key, we encrypt it with another key. That key is known as a key encryption key or a wrapping key. Sometimes you'll see it referred to as. Okay. And so encrypting the data key this way is more efficient than re-encrypting the data under a new key because it's quicker and produces much smaller ciphertext because we're encrypting a key instead of re-encrypting data over and over again. And so this turns out to be really important if you're, for instance, trying to move data into a storage service. Moving that data around and encrypting it multiple times in different places and so on would be, from a performance perspective, very slow. So instead, we're going to encrypt keys, and I'll show you exactly how we do that here. And so encrypting the data key this way, as I said, it's more efficient. We can encrypt the key encryption key that we use to encrypt that data key under still another key, but eventually one key must remain in plain text so that the encryption keys can be decrypted and ultimately that ciphertext can be decrypted into plain text data. And this top level encryption key, I'll just go back here, is what we call the master key. So at the very top of the hierarchy, and I'll show you what that looks like here in a little bit more detail. Let's step through an example of envelope encryption. So in this example, we're going to encrypt some bulk data using symmetric key encryption. So we take some plain text data and a plain text key and apply AES 256 to it, which generates some ciphertext, okay? So some encrypted data here, which is then indistinguishable from random data. So if you looked at the encrypted data, it just looks like it's random data because now it's encrypted. All right, so now we'll store the encrypted data in some sort of storage. It could be in the cloud, it could be on-prem. There's obviously a whole range of options. And our plain text data key that we use to encrypt the data, that needs to be protected now. And we can't store that plain text data key with the data itself, because if someone got into where we stored it and they get access to the key, then if they had access to the algorithm, they could decrypt the data and get access to it. So what we want to do is protect that plain text data key. Okay. And so what we're going to do is we're going to encrypt that plain text data key. And again, with what we're calling a master key or a wrapping key, and what we end up with is an encrypted data key. Okay, so now that encrypted data key, since it's encrypted, can be stored, and it can be stored alongside of the encrypted data so that they can share, for instance, durability characteristics of the storage media that you're storing them in. All right. And so the issue is now we have this master key. And what do we do with that master key? We have to protect it, because if someone gets access to the master key, then they can decrypt the key encrypting key. The key encrypting key can then be used to decrypt the data key, and then the data key can be used to decrypt the data. So we need to be able to protect this key. So what we can do is we can wrap that key and encrypt it, several different times and create a key hierarchy. So we take the master key and we encrypt it, then we take that key and we encrypt it. We can take that key and encrypt it. But at some point, that we have to have a plain text key that's going to allow us to begin to unwrap all of the key hierarchy so that we can actually get access to the data. And this really is where a key management system can help. And Dave is going to talk about the key management systems in great depth later in the webinar. Okay, so just to review or to summarize what we talked about here, a data key is used to encrypt plain text data. That data key can be encrypted using a key encryption key or a wrapping key. These keys can be encrypted using can be encrypted several times to create a key hierarchy. And then the master key is at the top of that hierarchy and is used to decrypt the key hierarchy and ultimately get access to the plain text data. We'll discuss some of the AWS services that help manage key hierarchies and master keys, such as the AWS Key Management Service and the AWS Cloud HSM service. Okay. All right. So now let's talk about options. Now that we've covered algorithms and keys and how we do envelope encryption, let's look at the options for encrypting data at rest in AWS. There's kind of two categories here that we're going to talk about. So the first category is client-side encryption. The concept here is that before the application that is generating or processing data transmits that data anywhere, it needs to encrypt it. And so the application needs to be able to encrypt the data, and it needs keys to do this, as we've just discussed. All right, and AWS offers some helper tools for customers that want to do client-side encryption. For example, the AWS Encryption SDK that we'll talk about. This can help you simplify the encryption, decryption processes, and there are some AWS services that have dedicated encryption clients like the S3, EMR, and DynamoDB, and I'll walk you through what these look like here in a second. And then you can use keys from several different places, including the application could generate keys for you, on-premises key management solutions, and cloud-based solutions as well. So you've got lots of flexibility for key management. And when you use client-side encryption, you are responsible for the proper implementation of the algorithms and the encryption and the decryption. So you're taking on more responsibility because you're implementing the client-side algorithms and key management mechanisms potentially yourself. Okay. The second option that we'll talk about is server-side encryption. And this is where you're asking the service to encrypt and decrypt data on your behalf. Okay, so the service is responsible for all the encryption and decryption implementation details instead of the customer. All right, so let's dive deeper into both of these options, and that way you'll see just how much flexibility you have to meet your requirements and to mitigate the risks that are important to your organization. I'll start with client-side encryption, and this is one that a lot of customers I talk to, this is where they started on their journey when they first started contemplating moving to the cloud. This is an option that they looked at very closely in the beginning. Okay, so client-side encryption, I'm going to walk you through an example here. So let's assume you're starting with data that's in your own on-premises data center. Okay, and that's what this is. This left part of the slide is your own data center. I know it looks simple, but let's pretend it's a real data center. All right, and let's say you have requirements to keep keys on premises and to encrypt data before transferring it. All right, so in this scenario, if you use the AWS Encryption SDK or the S3 client, okay, AWS can't see your data keys, and I'll walk you through how that works. And so you can generate keys within the application or get them from a key management infrastructure that you have on premises, okay, like an HSM, a hardware security module. And then you can use these keys to encrypt the data within the application, okay? Hopefully that makes sense. So far, so good. Now, then once you've encrypted the data using the keys that you have on-prem, then you can transfer the encrypted data into an AWS service that accepts data, okay? So notice in this scenario, the unencrypted data and the unencrypted keys were never transferred anywhere. They were actually kept on-prem. The only thing that was transferred was the encrypted data. And as we'll see, it can be helpful to transfer a encrypted version of the key as well, okay? And now another option you have is instead of having the application sitting in your on-premises environment, you could actually have that application running in EC2 in an EC2 instance inside your own virtual private cloud. And so now you're running the application that's doing the encryption in the cloud. And that way you can get all the benefits of the cloud, the scalability, the agility. You can avoid all of the costs of your own data center and so on. Okay, and so now you can run that encryption process from within your own VPC. And you can manage keys here as well. For instance, if you wanted to keep the keys on premise, you can still do that. You can have your application reach out from inside of your VPC and your EC2 instances back into your on-prem data center, into your on-prem data key management infrastructure, and get the key from there, decrypt the data inside that EC2 image, and then destroy the key, like throw the key away. And now you have data in clear text sitting inside that infrastructure. Okay, so it's just another option if you want to manage keys on-prem. You can do that even if you're running your application from the cloud. Okay, another option you have is to run that key infrastructure in the cloud as well. And so this can be another VPC, another virtual private cloud that you manage that only you have access to, and you can have the key infrastructure inside that VPC. Another option is to have a third party do it for you so that you have a separation of duties. So this could be an AWS technology partner, and there's plenty of them. I'll show you a very partial list here later, but you can have a trusted third party also provide keys in the cloud and do the key infrastructure for you. And that way you have a separation of duties. Okay. And then finally, and this is what Dave will talk about later in the presentation, is you have a bunch of options inside of the cloud as well for key management. And so if you wanted to use native management services such as AWS KMS or AWS Cloud HSM, or there's a combination of those two that you can use called custom key store, you have all of those options. And then one that I don't actually have drawn on the slide that you have is you could take that key from your own on-premises key infrastructure and import that into AWS KMS, for example. So if you wanted to control the durability and lifetime of that key, you can export it from your own HSM if your HSM supports exportable keys, and then import it into AWS KMS. And Dave will talk a lot more about this process in a bit. Okay, so that gives you an overview of what that looks like. So let's look at one of these options a little closer. So in this example, we're going to use client-side encryption, and we're going to keep the keys on-prem. And we're never going to share the encrypted data, the unencrypted data or the unencrypted keys with AWS, okay? We're going to use the Amazon S3 encryption client to encrypt and decrypt an object and store it in S3. And then we're going to keep the data key on-prem, all right? And I'll show you the code in a minute, but essentially, our application tells the S3 encryption client to generate a data key and then uses that data key to encrypt the object before putting it into S3. And then your application encrypts the data key using a master key that you have in your on-prem key infrastructure, for example. And now the encrypted data and the encrypted data key can be stored together in S3. And then the only way to get to the clear text or the plain text is to get access to the data key and the data, and then decrypt that data key and use it to decrypt the data. Okay, and the master key is required to decrypt the data key, and it never leaves your on-prem data center. Okay, so that's the scenario. Now, to decrypt the application first has to authenticate, has to be authorized to download the object from S3. Then the application gets the master key from the on-prem key management infrastructure, decrypts the data key, and then uses the data key to decrypt the object. Okay. And then you have several options when it comes to programming languages that you can use to perform this encryption and decryption, as we're discussing here. There's a bunch of SDKs, and so you have options based on the type of application you're using and the type of language you're going to use for that. So let me walk you through sort of what the application looks like, looking at some simple code here. So this is just a code snippet that you can see to show you how simple it can be to implement something like this scenario that we're talking about. You can get more complete code snippets from the URL at the bottom of the slide. So if you actually want to get access to this code and compile it and run it and so on, you can do that from the URL on the slide. All right. So what we're doing here is, after setting up some variables, including the one there that you can see called master key name. Okay, that's where we're going to put our master key into that variable. Then we go ahead and we tell the encryption client to generate a new AES 256 data key, and we call that SIM key. So now we actually have a new AES 256 key that we're going to use for encryption. And then we're going to save that to the local file system. This could be, any kind of infrastructure, really. Again, it's code, so you have lots of options. So we're going to save this to the local file system in this particular example, and we're going to encrypt it as we do that using that master key. Okay, so we have a master key, we're encrypting the data key, and we're storing it on the local file system. And then this call here is just loading the key back into memory so that we can use it for encryption. Okay, so now that we have a key to use called SIM key, here we're going to tell the Amazon S3 encryption client to use that key, and then we're going to upload the object into S3. So what it's doing here is we're telling it to use SIM key, which is our AES 256 key, and then when we tell the client to upload it, it uses SIM key to encrypt the object and then put it into S3. Okay, so the client actually uploads the encrypted data key as part of the object metadata. And so the reason why it does this is that metadata will help the client find the correct master key on-prem when it needs to decrypt this object. Okay, so this is what the decryption call looks like. The object metadata is used to help the encryption client determine which master key to use, because you could have a whole bunch of them on-prem, and then to decrypt the data key. And then the client uses the master key to decrypt the data key, and then uses the data key to decrypt the data. Okay. All right. So this is what it looks like. I've got an animated slide here to show you when we run that code. Theoretically, this is what would happen. So first, you provide the application with the key from your infrastructure. Okay. And then you provide the plain text object that you want to encrypt into the application. The application is using the S3 encryption client as we discussed, and it makes the calls and encrypts the data. And now the output is encrypted data and an encrypted data key. Okay, and it uploads that into S3. Okay, and then to decrypt, it's the opposite, right? The reverse happens. The object and the key are downloaded. The client uses the metadata that was included with the encrypted object to decide which master key to use. So now it's able to find the right master key. Then it uses that key which master key to use. It uses that key to decrypt the data key that was also stored in S3, and then decrypts the object using the plain text data key. And now we have plain text data back in our data center. So notice that the plain text object and the plain text data key were never shared with AWS, because you had your master key on-prem and you did the encryption on-prem. Okay. So sometimes when I show CISOs and CIOs and CTOs this, they say, well, that's good, but that's an easy scenario because it's just storage. Nothing was processed, nothing was shared across services or anything. So I'll quickly walk you through the same sort of client-side encryption example here, where we keep data keys on-prem, but this time we're focused on an Amazon DynamoDB database. Okay, so this is a database service in the cloud, and we're going to use the DynamoDB encryption client to do the encryption. And this encryption client is capable of encrypting data on an attribute by attribute basis. So it can also sign values to detect if values change or things are being added or deleted to the database. So it's got a signing capability as well. And we're going to avoid encrypting database keys. And so if you encrypt the keys themselves, like the actual database keys that are used for search and sorting, then you'll break the database, right? So we want to make sure that we're encrypting data, but we're not encrypting keys that the database actually needs to function. Okay, and so for this reason, you want to make sure that if you're doing this, you're not putting sensitive data into key values, because they won't be encrypted. Okay, so what we're going to do is encrypt values that, data values, and I'll show you the code here in a second to show you how we're going to set this up. All right. Okay, so in order to do this, the encryption client can use keys specified as what's called a cryptographic key provider, or CMP, that you see here. This includes on-premises providers as well, so you can get keys on-prem. You don't have to use an AWS service to do this type of client-side encryption using the DynamoDB encryption client at all. But if you did, you could potentially simplify a lot of things. And again, Dave is going to show you a bunch around the key management services that we offer. Okay, so the DynamoDB encryption process, I've illustrated here on the slide. We're going to put the plain text item, which is like a record in a database, through what's called the item encryptor. And there are some attribute options that we can use, such as encrypt and sign, sign only, or do nothing. I'll show you how those are used when we look at the code. And then the item encryptor gets key materials from for encryption and decryption from a cryptographic material provider of your choice. And so the item encryptor outputs encrypted and or signed items depending on the attribute action specified for each attribute. Okay, and I'll show you what that looks like here in a second. And then like we saw with the S3 encryption client example, this client requires a data key as well, right? So it gets a data key from the CMP, as we mentioned. It also gets an encrypted version of the data key, and it uses these keys to encrypt and sign variables, or attributes, I should say, as specified by your application. And once it's done, it gets rid of the plain text data key. Since you have an encrypted version of that key, it'll store it with the metadata, again, as I mentioned earlier, for each item. And you'll be able to decrypt that key using the master key that the CMP used to encrypt it. Okay. So very similar to what we saw with the S3 encryption client, except this one is obviously designed for a database application instead of storage. All right, so to decrypt the data, we're going to take the encrypted and or signed items for input, as well as the master key, and then we're going to decrypt the encrypted data key, and then the item encryptor processes this and provides the plain text. Okay, so let's look at how this is implemented in code quickly. So up here, all we're doing is setting up some attribute actions. So we mentioned there's kind of three actions. One of them is sign only, so that we're not, for instance, a key that you would use for searching or sorting in a database. We're not going to encrypt that because that would break the database. But what we are going to do is sign it so that if those values ever change, we will be able to detect those changes. Okay, and then we have encrypt and sign, which means we're going to sign it and we're also going to encrypt it. And then we have an action that you'll see here later on where we do nothing. We decide not to do anything with a particular type of attribute. So here, as each item, each attribute inside of a record comes into this code, the code is going to look at the attribute name. If that name is called is a sort key, then it's going to sign it. If the name is test, then we're going to do nothing with it. So if we look inside this database later for attributes called test, the values of those attributes will be in plain text. And then finally, everything else we're going to encrypt. So if it's not a key and if it's not called test, we're going to encrypt it, okay, inside the database. And so when this runs, what we're going to see here is first we're going to make a call and pass along whether we're encrypting, signing, or doing both, depending on that attribute. And then we're going to write that record to the database. Okay. So this is what it looks like when it's finished writing the record to the database. Right here, all these attribute names, binary, example, numbers, partition attribute, sort attribute, and test, those names are all in plain text, okay, because those are the names of the attributes. But you can see here the values of the attributes have been encrypted. So all of these binary blobs that you see here, that's encrypted data. Notice we can't read it. Okay, it's encrypted. It's indistinguishable from random data. And then here's some of the keys that we talked about. So there's a partition attribute and a sort attribute. These are keys for our database. We did not encrypt those. and this is why you can see the values of them, value 1 and 55. And then the attribute called test, we chose not to do anything with that. We didn't sign it or encrypt it. And so you can see the value is called test value, and that's in plain text. Okay. Hopefully that's making sense. All right, so we looked at the Amazon S3 encryption client and the Amazon DynamoDB encryption client. You also have the option to use the AWS encryption SDK to implement your own client-side encryption. And as I mentioned earlier, this can reduce the complexity you have and save you a lot of time and potentially a lot of money because the encryption SDK is doing a lot of the work for you. What kind of work? Well, if you're not, if encryption's not your core competency, some of the decisions that you have to make and some of the technology that you have access to is complicated, right? And so the SDK allows you essentially to implement encryption best practices without having to get into all the details, like, hey, how do I generate a key? Which algorithm should I use? Where do I need to store it? How do I make this encrypted data portable? Like all of the file formats and all of these details, the SDK really does implement all of that for you and makes it much easier to do client-side encryption. Okay. And so there's several supported languages and algorithms for the AWS encryption SDK. And again, you can get the details on this SDK in the FAQ that I'm pointing to you at the bottom of the slide here with that URL. All right, so as I mentioned earlier, you have several different options around key management, and you can keep keys on-prem, you can have a trusted third party, you can put them in the cloud as we looked at. The key here is that you always own your data when you use AWS. And so you can decide, where you're storing your keys, how the encryption is working. Like you have all of those options, right? That's super important because there's risks that you might want to mitigate, and you can choose the right encryption and key management options to mitigate the risks that you're really worried about. Okay, and so finally, as you can see with this is the same slide I showed you earlier with a whole bunch of different options, and these options give you that flexibility that you're going to need in order to determine how you're going to mitigate these risks. How are you going to meet your compliance obligations? And you aren't limited to using just one of these options. You can use any of them as you want to, right? You can use a whole bunch of them in different ways, right? So you're not limited. You don't have to make one choice and use it everywhere. All right, and then I mentioned AWS partners. And so don't forget to check out the AWS technology partners and the AWS consulting partners that are waiting for you in the AWS marketplace. They can help you with encryption, they can help you with key management, and they can help you with many other aspects of data protection. So check it out. I've included the URL to the marketplace here at the bottom of the slide. All right, so now let's talk about the other category. We talked about two categories of protecting data at rest in AWS. The first one we just went over was client-side encryption. We went through a few examples of that. Now server-side encryption. So here, server-side encryption, as I mentioned earlier, you're essentially asking the service to encrypt the data on your behalf. And many AWS services, like many AWS services, support server-side encryption. So let's walk through a couple examples so that you can see how this works. So first off, we'll take a look at S3, a storage example. And using server-side encryption in S3, you have a unique data key per object that you put into the service. And you have essentially three options for server-side encryption in S3. So server-side encryption with customer-provided keys, server-side encryption with Amazon S3 managed keys, and server-side encryption with AWS KMS managed keys. Okay, so let's look at the server-side encryption with customer-provided keys. This option allows customers to upload objects to S3, and as they do that, the objects are encrypted by S3 using the data key provided by the customer. And so when the encryption or decryption operation is finished, S3 removes the encryption key from the memory of the service. So you're essentially uploading your key with the data, S3 uses that key to encrypt the data, then gets rid of the key, destroys it, and now the only way to get that data back in a plain text form is to supply the key again. If you lose that key, you've essentially lost the data because S3 is not storing a plain text version of that key anywhere. Okay. And it's worth reiterating, right? If you're using this particular model, it's really up to you to store that key and to manage that key on premises, or with, again, a trusted third party, or however you're doing that. But again, if you do lose that key, you're going to lose access to the object because no one will be able to decrypt that in any reasonable amount of time, especially with an algorithm like AES 256. Okay. All right, so let's just walk through what this looks like, the process looks like. The customer provides the key and the object to be encrypted and pushes that into S3. The S3 front-end web server receives these items via a TLS 1.2 tunnel connection. So that means that the data has been encrypted or protected in transit. And then the web server front-end encrypts the object with the customer provided key, and then deletes that key and puts the object into the S3 backend storage fleet. Okay, so it's being encrypted on the front end and then pushed into the storage fleet in the back end. And then that key that the S3 web server used to encrypt that data is then deleted. And again, the customer has to provide that key. When you download the data from S3, you're going to have to provide the same key, the same symmetric data key, to decrypt the data. And if you don't provide the same key, you will not be able to get access to the data. Okay, so here's a little bit of code to see how this is really working from the application perspective. Here we're going to set up, we set up some variables at the very top here, so you can see the variable called SSE key. Okay, so that's our server-side encryption key that we're going to set in our application. And then what happens here is the application generates a new AES 256 key and puts it into that variable called SSE key. And then next, the application will upload an object to the specified bucket, also providing the customer provided key. And also, as you can see here in the next call, the application will download the object from S3, and it needs to use the same key it used to upload the object in order to be successful. And then finally, the app will retrieve some object metadata, and it's going to have to supply the key there in that call as well. So looking at those three calls, you can see, for instance, when we put the object into S3, we're doing so using the key, the data key. When we're pulling the object out, we're using the same data key, and then when we're accessing the metadata, we're using the same data key. So the point here is, in your application, if you're using server-side encryption with customer-provided keys, you are providing the key for all of these storage operations. And if you fail to provide the key, the operation is going to fail. Okay. So another S3 server-side encryption option you have is the S3 managed keys option. So in this particular option, instead of you managing the key as the customer, this means that you don't have to provide the keys for all of these calls. Instead, Amazon's S3 infrastructure is used for the key management. And notice in the diagram that I'm showing you here that the keys are stored in hosts that are separate and distinct from those that are used to store data. And so they're different infrastructures. Again, there's a separation of duties there. That's an important nuance to understand. Okay. And there's a bunch of controls to help to protect data in Amazon S3. I wish we had time to go through them all because there's tons and tons of them. It's really good stuff. But we simply don't have enough time to cover them all here. What I'm showing you here is one of the concepts is called default encryption, so that when you, for instance, create a new S3 bucket, you set this default encryption. So for instance, here I'm setting it to AES 256. And this is going to use server-side encryption with S3 managed keys. And this means that if a user tries to upload an object into S3, into this bucket, and it doesn't have encryption information included with it, then the S3 service is going to encrypt it using this default method. and that ensures the data that is being uploaded into the bucket is actually encrypted. Without default encryption, what I'm showing you here is you can write a policy, so an S3 bucket policy to reject requests that don't have encryption information. And so I'm just showing you a couple of examples here of what that policy would look like. And again, I wish we had more time, but I simply don't have enough time to show you the third S3 server-side encryption option, which is encrypting with KMS managed keys. But luckily for us, Dave is going to cover KMS in gory detail in just a minute. Okay. All right. Now, using KMS, as Dave's going to get into here, has a lot of advantages. In my mind, one of the biggest advantages is the integration it has with other AWS services. And so, for example, back in June at the AWS Reinforce conference, it was announced that there are 117 services at that point that had some integration with KMS. So this integration is super powerful. And I'm going to hand it over to Dave to explain why it's powerful and dive right into key management. And I think, Ross, we have a survey question before Dave takes over. Okay, and so the survey question is, now that we've gone over client-side encryption and server-side encryption, and we've talked about the keys and all sorts of things here, which of the options that we discussed today do you think you're going to use to encrypt data at rest in AWS? Which one of these resonated the most with you? Client-side encryption, server-side encryption, maybe you're going to decide to use both of these, or maybe you're going to do something else. You're going to do none of these. Please help us out and allow us to learn from you. All right, so it looks like there's about a third of the folks say they're going to use server-side encryption, and then over 50% said they'll use both. Okay, that's very interesting. Thank you for sharing that with us. That's actually really interesting. Okay, with that, I'm going to turn it over to Dave, Mr. Dave Walker, and he's going to walk you through key management.
Thank you. So Tim has covered where KMS fits in the overall scheme of KMS encryption frameworks. Now let's actually have a little bit more of a look inside it. So KMS itself, it's a resilient service. It's deployed on a per region basis inside AWS, and it uses FIPS 140-2 level 2 hardware in order to actually protect your master keys. You actually control access to the keys and whether they can be used by different clients to encrypt, decrypt, or both, while KMS looks after the keys from the point of view of durability and scaling and so forth. And all the actual KMS API calls that you make are recorded in CloudTrail, which I'll be going into in a little bit more detail later. So this is essentially KMS at a moderate level view. It presents a regular RESTful signature v4 based API as per other AWS services, which I hope you already know and like. It integrates with the AWS SDKs, so which you use to do things like provision your keys, apply grants to them, just generally manage your keys and permissions on them. It also integrates with the Encryption SDK, which Tim has just talked about. And as Tim has also just mentioned, it integrates via service roles with those 117 other AWS services. Behind the actual RESTful front end and the IAM permissions needed to mediate access to that, you have a fleet of key stores per region. These are actually FIPS 140-2 level 2 validated, as I mentioned. There's the link down there to the actual certificate that is on NIST's website. Very closely associated with that certificate on the site is the actual evaluation report. And if you pull that up and look in section 2.1.1, you'll see a table which states that those backend HSMs are actually validated to FIPS on 40-2 level 3 in certain important areas, particularly design assurance, role services and authentication, and physical security. But the HSMs are actually level 2 overall, because that's where they rate in terms of things like electromagnetic interference, interface design, and so forth. So these are the third-party certifications that KMS is in scope for. If you haven't already had a look at our SOC 1, SOC 2, and PCI DSS audit reports, I'd encourage you to do so. Those are available on our Artifact service, which is available through the console. It's essentially a little self-service web portal. You'll also find in there our ISO 9001 quality manual, which is interesting reading if you want to get some insight into how our software development lifecycle works. But I digress a little. So let's actually look at how AWS and KMS between them use data keys. Really, it's there's two approaches. One is for EBS and EC, and also EC2 instance stores. These obviously are going to normally be fairly long-lived volumes. You have a data key per volume, and these are stored once KMS has actually decrypted them, either in the hypervisor for the earlier Zen fleet, or in the Nitro system storage for the more recent instances that we have. In the event of something going wrong with your instance, because as we all know, Werner says everything fails all the time, then we have the ability to go reprovisioning that key if we need to swap an instance over or reprovision it in the case of in the case of a failure. And a bunch of services use this particular model because they typically use EBS behind the scenes in order to actually store your data. S3, Tim's already mentioned a little bit about how S3 has its own front-end management servers. These also deal with your KMS keys. Again, you have a KMS data key per object, and those object keys only need to exist in the S3 front end when each time you actually access the object. So normally the EBS keys are longer lived in the actual environment that is doing the data processing. Also, it's worth bearing in mind that because an EBS volume is more likely to be very long-lived, but also have a lot of access over its lifetime in terms of reads and writes, compared to an S3 object. I mean, you may be reading and writing an S3 object fairly frequently, but chances are you'll be accessing storage on an EBS volume more frequently. We actually use a different mode when working with EBS volumes. Tim's already mentioned that KMS typically uses AES 256 GCM, so Galois counter mode, which gives you a 256-bit key space. On EBS, we use a token stealing mode, XTS, so that's AES 256 XTS, which effectively doubles the size of your key space, giving you a 512-bit search space, and therefore mitigating the key wear-out problem. As already been mentioned, Tim's discussed how you effectively have two tiers of keys, having your master key, which lives only in KMS in clear text form, and also your data keys, which actually encrypt your data. There's a couple of truths that kind of hide in plain sight in this diagram. The most interesting of which is that your data keys do not live in KMS. They live in the individual services that host the data that's being encrypted, actually alongside that data. This has some useful side effects and benefits in that if you consider a customer who has a particularly low risk appetite and is concerned about insider threat at AWS, for example, then because of the way in which services are provisioned and structured at AWS, under the big umbrella of AWS engineering, each individual AWS service operates semi-autonomously, it's fair to say, with oversight from AWS security, of course. But each is built and managed and designed and run by its own team. We call them service teams. And under appropriate circumstances, so from the point of view of debugging and so forth, there are means by which service teams can get privileged access to work on their service. But this means that if I was on the S3 team, for example, and I needed to do some work on S3, maybe provisioning some new front-end devices or whatever, then there is no way I could get access to the clear text of the data encryption keys that KMS was storing in S3, because those keys are encrypted with the master keys which are up in KMS. And as a member of the S3 service team, I have no means of getting any more privilege on KMS than you do. I would just be a normal user. So we actually have separation of duty enforcement on key access associated with KMS. Carrying on a bit more, just in a bit more detail here. So you have your data key, which encrypts your bulk data, as Tim's mentioned. That actually lives with your data in the relevant service. That gets encrypted by your master key. And those are actually encrypted under further keys that are actually stored in KMS itself. The individual HSMs operate as a fleet. They establish encrypted communications using ECDHE between them, so you've got perfect forward secrecy. And then they actually, excuse me, they are able to exchange key data among themselves so that clear text copy of your master keys is only shared among the HSMs in a region. Obviously, they're in different availability zones for resilience. For keys that we actually generate for you in KMS, when you say create me a master key, those master keys actually get encrypted using fleet keys up at the top there and stored in S3 for resilience as well. There are two kinds of master keys with KMS. There are ones that we manage, and there are ones that you manage. The master keys normally get referred to as default keys by each service that has KMS integration. It's fair to say that we create and manage those so that when you turn on encryption in an AWS service that has KMS support and you say go use KMS, if you have code that dates from before KMS had supported that particular service, you don't need to go changing your code in order for it to continue to work and for encryption to happen. The default key will just get used by default, funnily enough, if no other key is specified in your API calls. However, we do very much recommend that if you've got software that supports KMS and understands key management from the point of view of being able to reference a key that you want to use to encrypt when you're making an API call to encrypt or decrypt data, we do recommend that you actually provision your own master keys and use those. Also, it's a good idea to, if you're in a multi-account environment, it's a good idea to keep your master keys in the same account where the data is, And if you need to make calls to, for example, store data in a log bucket in S3 from another account, you can then actually grant cross-account access. And actually managing access to keys is what I'm going to get onto in just a minute or two. So looking at how a key actually gets used, you've got KMS with your master key in there. When you go doing something such as here on an EC2 instance, when you go doing something like mounting an EBS volume, first of all, if you're creating that volume to begin with, you wind up calling KMS with generate data key to say, I'm making a new volume, make me a data key to encrypt it with. If the client has the ability to use that key, then it is able to do so, as indeed are you. The data key is encrypted using an AES 256 key that was established using the ECDHE connection over the back channel to talk to KMS. So you wind up actually shipping the data key over the encrypted channel. So you actually ship two keys here. You ship a clear text copy of the data key for ephemeral use by the service, and you ship an encrypted copy of the data key, encrypted with the master key, to store alongside your data. And then those get actually returned to the client over that AES 256 encrypted channel with those keys negotiated over ECDHE. You encrypt your data, you delete the key when you actually don't need that encryption context anymore. So in terms of the clear text copy of the data key, that gets stored either in a hypervisor module or in the Nitro system. It's something that we cannot access. We cannot dump RAM out of Nitro or out of the hypervisor. Those keys are beyond the sight of AWS staff when they're actually in the client service. Now, you can also bring your own key. Some customers have needs to do this, and this is the one time at the moment that you'll actually see KMS doing asymmetric encryption. So if you need to bring your own key, you make an API call saying, I need to bring my own key. KMS goes and creates an empty container to put your key in. It then goes and generates an RSA key pair. It sends you one half of that key pair, which you then encrypt your key with that you're going to bring, and you then return that to KMS. KMS decrypts your key with the other half of the key pair, puts it in the container, and throws the key pair away, at which point you now have your own key material as a KMS CMK. Reasons why some customers may want to do this is some customers have particular requirements around key generation. Now, in terms of what KMS actually does, being a FIPS certified environment, we do actually use FIPS certified and FIPS approved random number generation for generating CMKs and indeed data encryption keys. But there are some customers who have a need to have harder assurance of random number generation. It's fair to say, actually, assurance of randomness of random numbers is one of the very, very few now remaining black arts in cryptography. And we do have customers out there who need to use things like quantum effects or radioactive decay as an entropy source for a random number generator. If you're in that camp, then this is something you can do. You can bring your own key. Also, regarding key deletion, when we create a key in KMS, when we create a master key for you, after you call the create a CMK API, we are effectively the custodians of that key for you. You don't get access to the key material at any point. So what this means is that if you go deleting your key and the key disappears, then any data that you've got encrypted using that key is now so much useless white noise. And in the early days of KMS, we had a few customers who did this, and then they went, oops, I've got this volume or this object that I'd sort of forgotten about, and it was encrypted with this master key that I've just deleted. Oh. So what we actually do is if you have a key that we have generated for you and that we are the custodian of, we require that when you say delete this key, there be a minimum 7 days. You can have it up to 30 days if you want to, a minimum 7 days during which the key is put beyond use, but which, if needed, then be recalled and brought back into service. So this is to mitigate the risk of you having an oops moment and realizing that you've got some data that you've got encrypted with the key that you're trying to delete. By contrast, if you bring your own key, you've got the key, you are the custodian of the key, and you're just giving us a copy of it. So if you go deleting the KMS copy of a key that you have brought, then should you find that you have an oops moment, you should be in a position to bring another copy of the key again yourself in order to mitigate the issue. So if you have your own key management and your own key management environment on your premises, bring your own key is a suitable approach if you're in the circumstances where you need to. All this about how we actually handle the keys is described in the KMS FAQ and also in the KMS Cryptographic Details white paper, which I would very much encourage you to read if you would like exhaustive detail on how KMS actually works. So as I said, KMS is a per region service. Keys aren't replicated out of region. You can actually use the AWS Crypto SDK in order to manage replication of keys across regions so that you can transfer data across region and as ciphertext and then decrypt it at the far end. Alternatively, for S3, there is an S3 cross-region replication API call, and you can do dynamic decryption and re-encryption with different region keys on the fly in that. There's actually an item in the last bullet point here again that's worth calling out, which is that there are certain operations which are particularly security sensitive in the KMS backend. So things like introducing a new HSM into a region's fleet or removing one from a fleet are obviously important and highly security sensitive things to be doing. And what we have there is we have our own system of what we call quorum commands. So what this means is that no individual member of the KMS service team is able to perform this action on their own. If you're familiar with the AWS SIG-v4 API call standard, where you have your API call, a few other parameters, including your AWS access key, and then you take a derived HMAC over that using your AWS secret access key. Effectively, what a quorum command does is much the same thing, but wrapped again in another layer of access key and secret access key HMAC, so that multiple people need to sign the API call in order for it to succeed. There are some calls that require 2 people, there are some that require 3 people. So this means that highly sensitive operations always require multiple eyes on the operation being performed. So again, in terms of service team access to KMS, there is no API to extract keys in clear text from KMS. Customer master keys, once they're in KMS, aren't coming out in clear text. And actually, if you're familiar with HSMs, which I'll be getting onto shortly, the way in which you manage access to a key and work with a key in KMS, it looks very much like how you'd work with an HSM, but with the ARN of the key, so the AWS resource identifier being very much like a PKCS11 slot number. The HSMs actually boot off of read-only media, so the software update process requires a bunch of hoops to be gone through in order to replace the media. And when the media actually is replaced, that requires a reboot of the HSM, which of course wipes all the keys in RAM from it. It's also very important to note that all KMS API calls turn up in CloudTrail, even those that we actually make on your behalf, more on which in just a moment. When it comes to handling access to your keys, keys have policies associated with them. You can have IAM policies normally used in combination with those, but certainly if you're assigning if you're assigning permissions to software, so either software that you're running on your EC2 instances using IAM roles on the instances, or IAM using software in containers or Lambda functions, key grants are a thing that we very much encourage you to look at. Grants are a lightweight policy mechanism that it's easy to set a grant up and revoke a grant programmatically rather than have to go dealing with IAM policy. So if you're provisioning and deprovisioning things in a highly dynamic environment, or you're actually using privilege bracketing where you only want to grant permission to use a key for as long as use of the key is needed, then key grants are definitely the thing to look at, and the developer guide will give you a bunch of information on that. So if we take a look at an example piece of policy here, we have, just as this example, we have the ability to both encrypt and decrypt using this policy. You don't have to have both if you don't want to. You can, and it's quite common to do so when, for example, setting up writing of logs to log buckets. You can set things up so that your entity can encrypt only rather than decrypt. So again, this acts as a further layer of control over the data that's being written, as well as the access policy on the S3 bucket and the objects within it. And you can also see here that we have permission to use these two keys, which are represented by these two arms. You can also, particularly when human access is involved, have an IAM policy that again gives you specific fine-grained IAM actions against KMS, and you can also put the usual IAM conditions on your policy. So, for example, here we have a requirement to authenticate with a time-based one-time password multi-factor authentication token. Keys also have a thing we call encryption context. It's an optional thing. We do encourage you to use it. It is a little bit misunderstood. There's a popular misconception about encryption context that it's actually a salt on the key, and it isn't. The encryption context is not a secret. It's essentially another bit of check and balance that you can apply to ensure that you're using the right key for the right thing. I mean, the key for an ARN is not that human readable a thing in terms of being able to discern by looking at the ARN what the purpose of the key is. So you can use an encryption context as a further check and balance to ensure that you're actually using the right key for the right purpose. If you have, and we recommend you do, have different keys for example, writing data to your log bucket in your logging account versus mounting an EBS volume handling sensitive data within an application, for example. You want to be using different keys for that, and you can ensure when you pass an encryption context string to use your key that you're not going to be using the wrong key, because if you reference the wrong key but pass the right encryption context, then your encryption operation doesn't happen. And similarly, if you pass the right key identifier but the wrong context, again, you're failing safe. Now, in terms of what actually gets logged in CloudTrail, this actually is the anatomy of a CloudTrail record. So you can see which action was being called, when it was being called, which key was being used, what resource is associated with the operation. Okay, so you can see also the encryption context. So as I said, it's not a secret. It exists as clear text. It goes in the log. You can see the IP address from which the call was made, and you can also see the AWS user. This is an interesting point here, in that there are some KMS operations that we actually perform on your behalf. So as we saw earlier, if you're doing something like mounting an EBS volume from an EC2 instance, if that volume is encrypted, there needs to be a KMS decrypt operation performed. That's something that we do as part of the mount operation. You will still get a CloudTrail record, but you will see that the user in that record is marked as AWS internal. Okay, right, so hopefully that makes sense for KMS. If there's more that you'd like to know about it, then please ask us, please post some questions on it in the webinar chat. Meantime, I'll go on to Cloud HSM. So we've already got KMS. Why would you need an HSM? Well, there are certain circumstances, and particularly regulatory requirements, where standalone single-tenant hardware security modules are mandated. It's fair to say, though, that KMS is by far the more commonly used service. There's trillions of operations performed annually, millions of accounts having KMS keys. Cloud HSM is a rather less used service, because in practice, when you start looking at HSMs, I normally only see them in high threat club elements of public sector workloads, and also in financial services, particularly when doing things like integrating with payment gateway services. So Cloud HSM is a hardware security module, funnily enough. We do a bunch of the management on it so that you don't have to. And if you've ever actually had to manage a hardware security module or a fleet of them yourself, you'll realize why this is a good thing. Managing hardware security modules is not for the faint of heart, and it's fair to say they are not the easiest things in the world to manage, especially given the value of the data they're actually holding. The way in which you provision Cloud HSM is as part of a cluster. You always want to have no single point of failure in a hardware security module environment, so you can actually divide your HSMs across availability zones in a region. Cloud HSM, just like KMS, is a per region service, and they appear as a network resource in your VPCs. Load balancing across HSMs in a cluster is automatic. We actually deal with that for you. And what you can actually do when backups are taken of your HSMs, which happens either every 24 hours or every time an HSM is created or deleted, you can do a cross-region replication of the backup of your HSM, so that if you have a requirement to keep copies of your HSM managed keys in multiple regions, then that's something you can do. You can even actually, when you've made a cross-region copy, you can actually stand up a new HSM cluster in the other region, which is then a clone of the HSM cluster that's in the origin region. Again, this means that you can bring HSM encrypted data cross-region and decrypt it in the destination region if you as and when you need to. So people use Cloud HSM typically to offload TLS processing for web servers. So you can have your private keys stored in an HSM. There's various plugins for various servers for doing this. Normally, HSMs wind up getting used a lot in PKI environments, so you can use them in the context of your, particularly your root CA. We now have private root CA capability in AWS Certificate Manager as well, and that actually uses HSMs on the back end. If you're using transparent data encryption on your Oracle databases, you can use an HSM to unlock the soft key store that then decrypts your tables. And there's code out there that will integrate typically either with PKCS11, which is the industry standard API set for dealing with HSMs, or indeed Cloud HSM can act as a crypto provider to the Java crypto engine. There's a couple of Microsoft SDK APIs it works with as well, so CNG and KSP is my understanding, if you need to use those for signing or indeed DRM. So from the point of view of control, with Cloud HSM, you actually are the crypto officer on your HSM. So you get to determine what algorithms are used, what key lengths are used, how users are managed on the HSM. You have the ability to provision your own users, up to 8 of them per HSM. Again, in the context of where people need to use HSMs, it comes down to if you need to have a FIPS 140-2 level 3 certified environment specifically, which, as I said, I really normally only see in High Threat Club and also in Payment Gateway. But also, if you need to do crypto operations using algorithms other than AES-256, which at this point is the only algorithm that KMS understands, if you need to use other algorithms inside a FIPS environment, then Cloud HSM is the service you need to be looking at. With great power comes great responsibility. So again, you need to be looking at managing your users. You need to be looking at integrating your applications. But other things, we actually do the heavy lifting for you. So high availability is taken care of by Cloud HSM clustering. Provisioning is something that you just do with a couple of calls through the Cloud HSM service API. We manage maintenance for you. Cloud HSM actually logs to CloudWatch, logs. It also sends health check data to CloudWatch, which we observe. So if there's any hardware breakage in an HSM, we will replace and reprovision the broken HSM for you so that your cluster is only down an HSM for a modest amount of time. So again, looking at that in a bit more detail, we actually do your logging, we do your backups, we do your high availability as mentioned, we do your provisioning, we look after HSM healthcare for you, and we manage your backups, which I'll get onto in just a moment. Application integration is still something that you need to do using the SDKs, the HSM support, user management I've mentioned, which is something that you can do using the Cloud HSM management util that we make available for the purpose. And logging, as I said, that actually goes to CloudWatch logs. So we also patch the HSMs for you, and the way in which they appear to you is as a network resource. They present a network interface inside your VPC, and when you're actually working with the Cloud HSM client, you actually establish an encrypted connection between your client and the HSM itself. There is a key, there is a certificate key exchange at the HSM end, so you can pull the certificate for the key associated with the HSM and validate that validate from the certificate, which has a global global anchor of trust, that you're talking to a proper HSM. So looking at the cluster architecture, the way in which you grant an instance or a container or a Lambda function the ability to deployed in a VPC to connect to an HSM is by assigning the security group that is given to you when you provision your HSM cluster to that network interface. You need to obviously install client software on your client in order to talk to the HSM, but that is easily done, and we make the software available for you. You can have up to yes, up to 1,024 users. I was remembering the wrong line here. You can actually create and manage up to 1,024 users on your HSMs. Each of those can create and manage keys that aren't visible to other users, but you can share a key with up to 8 other users. We have no access to the keys. And again, there's FIPS boundaries in place that actually enable you to assert that to your auditors. In terms of separation of duties, firmware that we install for maintenance and management is provided by the HSM vendor. We look at, we essentially do husbandry of the HSMs themselves in terms of creating them, zeroizing them when you decide to delete them. We update the firmware, we back them up, we restore them, we deal with the clustering. You deal with everything else. Backups are an interesting thing to look at as well in terms of how we can't get access to them. So when you back an HSM up, the backups are encrypted using a key that is derived from 2 separate keys, one of which is in the HSM intrinsically, the other of which is one we supply. So there's a key derivation function used to generate that, but we don't know what that key is, and it gets stored with your backup. As I said, you can clone this across, you can copy this across region, you can use it to clone HSM clusters, and when you go provisioning a new HSM, what it's actually doing silently behind the scenes is restoring from a backup. Now, there is now a mechanism for integrating Cloud HSM as the key management backend to KMS. So again, this is for customers who actually need to have FIPS 140-2 level 3 certified environments specifically. And again, this gives you the ability to audit your keys independently of KMS, should you need to. The way in which this is actually set up is reasonably straightforward. What you wind up doing is giving KMS a set of credentials for your HSM so that it can use a connector in order to go and talk to it. An important thing to bear in mind is at this point in time, you can't actually use bring your own key with KMS once you've got a custom key store backend set up. If that's something that you think you would need, then please talk to us. Obviously, if you're using hardware security modules, you have more responsibility. So you still need to manage your hardware security modules. And you still need to look after your hardware security module backups. And we have another survey question.
So of the key management services that Dave described today, which of the services are you most likely to use? So the AWS key management service, the Cloud HSM service, the custom key store option, all of them or none of them? Please share your thoughts with us.
While you're doing that, one more thing about Cloud HSM. If you already have an on-premise fleet of HSMs and you need to migrate keys from those into Cloud HSM as part of a workload move, for example, if your on-premise HSMs support KMIP, then you can actually use KMIP to import your keys into Cloud HSM. You need to use a third-party piece of software to do that, which is available on an AMI in the AWS Marketplace. But if this is something you need to do, then please engage our services.
All right, so we have the survey results here. It looks like 68% said they were going to use KMS.
Excellent.
11% Cloud HSM, and 2% the custom key store option, and just under 20% all of them. Very interesting. Thank you to everyone for sharing those insights with us.
Yeah, Cloud HSM is a specialized service, but if you need it, it's there. And so, thanks very much, and back to Tim.
All right, thanks, Dave. Great as usual, very informative. Okay, so just one final small section here to go through is we've talked a lot about encryption and key management. We've gone through client-side, server-side encryption. We've talked about KMS and Cloud HSM and custom key store and a whole bunch of stuff. There's a ton of stuff we went through here today. You might be wondering at this point, well, which of these options should I use? And so we wanted to provide you with a little bit of insights and guidance. And so from my perspective, I've been talking to customers a long time about this stuff. Some of the customers I meet with, and they're first contemplating using the cloud, they're, the very first thing they start looking at is client-side encryption. They want to do everything client-side. They want to keep the keys on premise. They want to be able to mitigate any threat to unauthorized access to data. And over time, what I've seen is that once they realize, they go down that path and they realize how much complexity is there, the complexity around key management that they're managing on-prem, the extra code in all the applications, including extra costs because you're moving things in and out of the cloud all the time. They'll start that way, but then very often what they do is they look at these other options around key management that Dave mentioned, and they see that these also mitigate the threats that they're actually worried about. So once they dive deeper, especially into KMS, they realize that integration with those 117 plus services at this point, that is super powerful, and it gives them many of the same security characteristics that they're looking for. And so I encourage you, if you are considering client-side encryption, or if you're considering Cloud HSM, do a deep dive into KMS, because chances are the types of threats that you're worried about can be mitigated using that model, and doing a deeper dive into KMS and really taking a look at how it's being integrated into these services and how it works is going to save you a lot of time, probably a lot of money, and it's just really worthwhile taking a look at KMS. Okay. Now, some of the considerations when you're trying to make up your mind, which route would you go on for a particular application, for instance? Some of the key questions: where are the keys generated and stored? Is it on hardware that you own? Is that a requirement, or can it be a cloud provider that owns that hardware? Where are the keys used? Is it client software that you control, or is it server software that the cloud provider controls? And then who can use the keys? Users and applications that have permissions, or cloud provider applications that you give permissions to. And then finally, what assurances are there for proper security around keys? And so can you get access to audit reports like a SOC 2 Type 2, like a C5, and others? So those are some of the considerations. If you're deciding to use, for instance, the key management service, you'd consider KMS if you need to secure your encryption keys in a service backed by FIPS validated HSMs, as Dave described, but you don't necessarily need to manage those HSMs yourself, because that will save you a lot of administration. If you're looking for FIPS 140-2 level 2 overall validated HSMs, KMS is going to be able to meet that requirement. And then if AES 256 symmetric encryption meets your requirements, then it seems like KMS would be a good choice for you. Cloud HSM, on the other hand, as Dave mentioned, it actually solves some problems or some requirements. For instance, if you need keys stored in a dedicated third-party validated hardware security module under your exclusive control, so like single tenant, you need FIPS 140-2 level 3 validated HSM as opposed to the level 2 that we saw with KMS. If you need asymmetric encryption, Cloud HSM does this, but KMS doesn't. And then, as Dave mentioned, some of these APIs like PKCS 11 and some of these other interfaces, then probably Cloud HSM is going to be the service that you want to take a closer look at. And then finally, with the custom key stores, if you require keys protected again in a single tenant HSM or an HSM that you have direct control over, and you have an explicit requirement for HSMs, again, validated FIPS 140-2 level 3 overall, and then you have keys that are required to be auditable independent of KMS, then this custom key store option is something that you want to take a look at. Okay. All right, and so with that, I'll just share these resources. There's tons and tons of good videos from past reInvents and Reinforce conferences. Some of the folks in the videos and some of the white papers that you see here really are good. Highly recommended. The one that Dave mentioned earlier, AWS Key Management Service Cryptographic Details, that is like a 40-plus page deep dive into all things KMS that you can get into it and see the discussion around the internals and how the keys are being managed and so on. So that one's highly recommended.
Yes, it goes into the maths of how envelope encryption works even.
Right. Yeah, that's a really good paper, and it's updated over time as well. So other than that, you can see a ton of stuff here. I included a GitHub resource here on encryption and KMS workshops in AWS that some folks here at AWS developed. So if you're looking to actually get your hands on bits and do some hands-on keyboard stuff, that's worth taking a look at as well. But thank you very much for joining us today. Really appreciate it, and happy encrypting.